are going to discuss the lectures nanotechnology in chemical engineering. So today we'll discuss about the application of nanoparticles in enhanced oil recovery. So in enhanced oil recovery, so there are various type of nanomaterials or nanoparticles that can be used to improve or enhance the oil recovery from that ores. So in earlier actually different type of solvent fluids that have been used. So to improve the efficiency or performance of the oil recovery from the rig. So nanoparticles also play significant roles to enhance the recovery of the oil from that ore. So that we particularly discuss. So how nanomaterials by using different type of polymers or surfactant. So nanoparticles with surfactants or nanoparticles that would be used with polymers that can be polymers, so that can be improved the enhancements of oil recovery. So before that we will discuss. So when crude oils, that is very important from chemical engineering aspect. So crude oil, that is remains, that is one of the most treasured, valued and predominant natural resource in the great human societies on the planet of the earth. The discovering of the oil's reservoirs is difficult, and 30 to 60% oils remain trapped in the current producing reservoir. So currently whatever the reservoir that we are using, so we are getting the oils from that rigs, and 40%, 10 to 40% we can get from there, but after that 30 to 60% oils remain trapped inside of that reservoirs. So therefore it is importance means to get that amount 60%, 30 to 60% that oil to remain trapped inside of the reservoir to take out. For chemical engineering point of view, different type of methods are there to get those trapped oils. So earlier usually different type of surfactant or polymer fluids that is commonly used to recover those oil present, that is in the form of trapped oils that is present in different rocks or reservoirs that can be coming out. But here's a different type of nanomaterials. I said nanomaterials has unique properties, it having high surface area to volume ratio, weight, and these nanomaterials can control the weightability of that fluids or oil that is present in that reservoir. Also that nanomaterials change the interfacial tensions in between oils and that rock that is present inside of that reservoir. So it can lower or reduce the interfacial tensions IFT, so that can reduce or lower. So as a result the trapped oils we can collect or we can recover. So here some nano with these polymers, I said different type of surfactants, polymers, fluids that can be used, and with that some nanomaterials also can be incorporates with that fluids. So nanomaterials that may be 1 to 10 100 nanometers within that range that we can use to recover that trapped oils that is present. Okay. So these nanomaterials will be added with the base fluids. So here base fluids may be surfactants or polymer. So with that nanomaterials will be added, and then the property of the base fluids, that is the surfactant or polymers, that would improve or change. So as a result that would change the performance of that fluids to recover the oils that is present. So actually the role of nanomaterials, that nanoparticles that will increase that would be used a specific percentage, very low concentrations that would be used with the fluids, that is surfactants or polymers or any water based fluids that we can use. So with that nanomaterials, actually these nanomaterials change the rheological property of the fluids at different temperatures. The role of nanoparticles that is present in that, or that is we are using with the fluids, so it reduce the interfacial tension, I said, weightability alterations, heavy oil swellings, asphalt stabilizations, reducing the viscosity of the oils and increasing the viscosity of the injected fuels, and nano emulsion creations, port channels flagging, and disjoining pressures. These are the means roles of nanomaterials that is coming to these fluids, base fluids, and change or alters are different properties of that oil that is present in the reservoirs. Okay. So here you can see one schematic diagram is showing. So use of nanoparticles, that is for enhanced oil recovery applications. So here you can see this is the blue colors, that is you can see that is the fluids or nanofluids, you can see with that different nanoparticles that is present with that fluids. So here's black colors, that is the oils that is present, and this is solid surface, this is rock you can see, or solid surface. So with that there are means they're attached, these oil particles is attached with that salt or sands. So when nanofluid we are passing, they actually disjoining this pressure. So disjoining the pressures means in between oil and solid surface, nanoparticles disjoining the pressures, and as a result the oils, trapped oils may come out from that surface, also creating nano emulsions, means nanoparticles when that is present with the nanofluids. These oil particles, this is oils, this is fluids, and they forms a nano emulsion. So as a result the trapped oils we can get out from there, and also weightability alteration. So here's oils and solid surface is there, so I say that it's disjoining the pressures as well as weightability alterations in between oil and the solid surface there's present. So nanoparticles this way change or alter or reduce that weightability between oil and solid surface or the sands. By that way it can improve the oil enhance, means recovery, we can get more amount of oils. Also it can port channels plugging. So these nanomaterials, that there are so many channels or plug is there, so that would be plugged by that nanoparticles. Okay, so these are the different way nanoparticles helps in enhancing the interfacial tensions of that fluids, or improve the surface activity, viscosity or surface property of that fluids. So by that way we can enhance or increase the oil recovery from that rigs or that particular reservoirs. So here different type of nanomaterials or nanoparticles, that is silica, alumina we can use, or irons we can use, or maybe two different type of nanomaterials, that is silica, alumina, different ratio we can use with that surfactants or polymers. With that we can prepare say fluids that can be useful for this oil recovery. So here in basics about the oil recovery, so there is the, I said, primary phase, secondary phase and tertiary phase. So in primary phase we can get that oil that is present in the reservoir, secondary phase also some more quantity of the oils we can recover, and tertiary productions here actually requires to increase the reserved or recovered oil, so that we can enhance. So here's three different phases of oil recovery that we are showing here: primary phase, secondary phase and tertiary phase. In primary phase approximate 10% that oils that we can get or recovered, that is due to the gravity drainage, and in secondary recovery there's 20 to 40% out of the totals, that is the amounts of oil is present by injecting gas or water floodings or pressure maintaining, we can get that amount of oils, and rest this 30 to 60% that is present, that is tertiary recovery. So in that stage actually nanoparticles is recovered. So earlier there are thermal methods, gas injections, chemical methods that can be used, but nanotechnology that helps us to improve that recovery of that trapped oil is present. Okay, so these are the things already I have discussed, so I am not going to discuss more details about this. This in tertiary recovery stage where we can get rest of the oils, that is thermal techniques that can be used, so that is commonly steam is used, and chemicals methods that is used for large scale productions. So here you can see in the tertiary recovery, that is the way that we can recover the trapped oil. So here thermal methods, different type of steams we can use, but in using these steams interfacial tensions that would be reduced, at the same time high energy cost in this particular thermal methods. And in chemicals method different type of alkali we can plant, we can surfactants we can use, polymers we can use, or alkaline alkali surfactant or polymers we can use to reduce the interfacial tensions. However this is also cost effective, so cost effective process, and however with that if we are use nanoparticles, so then slightly the enhanced capacity and recovery capacity that will gradually increase. So here the role of surfactants, here I said the in chemical or enhanced oil recovery process, there we can use alkali surfactant or polymers that fill fluids that we can inject. So individual fluids we can inject, or combinations of two different fluids, or maybe alkali surfactant polymer mixtures that we can use, that actually changes the interfacial tensions I said, also decrease the capillary pressures and increase the sweep efficiency. So here's I said different type of nanomaterials, but all nanomaterials we cannot use. So here it has been observed that when alumina and silica, that nanoparticles are used for that enhance oil recovery with that surfactants, it reduce the viscosity or interfacial tensions and enhance that oil recovery. Silica based also nanoparticles that is dispersed with ethanols and increase the oil recovery by changing the or altering the weightability of that oil that is present in that oil reservoirs. Okay, so but MgO or zinc oxides, that nanoparticles with distilled waters or brines we can use, but the performance is very poor in terms of oil recovery. Okay, that performance is very poor in these two nanoparticles. So alumina and silica, that is very effective nanoparticles that we can use for this oil recovery. So here's I said initially waters would be flooded, then polymer floodings, and then polymers with nanomaterials that would be flooded for enhanced oil recovery. So by that way the performance of oil recovery that would enhance. Different type of polymers that can be used. So synthetic biopolymers or polyacrylamide, polydimethyls, dialyls, ammonium chlorides, different type of biopolymers also, epoxy polymers also can be used for this particular process for polymer floodings. Okay. So here the amount of the nanomaterials, that either it is silica or alumina, that nanoparticles that we are going to use with that polymers to prepare nano polymer fluids that would be used for recovery of the oils. So here's actually polymers, whatever we are using, the polymers actually adjust on the surface of the carbonate or sandstone or rocks that is present. So that adsorptions of the polymer solutions in that rocks that would be adsorbed, so that we can reduce by using nano clay or nano silica. So then if we use 2 to 3 weight% of the nanoparticles in that polymers, so compared to the only polymer flooding, so 2 to 3% of nanoparticles in the polymers we can mix up, and that we can use as a fluids, nanopolymer fluids. So that recovers or increase approximate 4 percentage of oils that would be recovered or increase that amount. With nanopolymers, that nanoparticles and 2 to 3%, 2 to 2.38% of nanoparticles we can use with that polymer. So now nano surfactants, with nanoparticles we mixed up with that surfactant, different type of surfactants are present, and that can be considered as a nano surfactants that can be used as a media for this oil recovery. Here's actually depending upon the pores that is present in the reservoir, so concentrations also we can vary, either low concentrations or high concentration. If the large pores volumes is reservoir present, then low concentration of the surfactant solutions that we can use, and if a small pore volumes is present up to 20% in the reservoir, then high concentrations of the surfactant solutions we can use. So now role of nanoparticles that we discussed. So here's nanoparticles actually how that works when that is the oil is trapped in that rocks or that is reservoir. So actually the nanoparticles decreasing the contact angle between the fluids and solids. So this is the fluids and this is the solids. So here they are trapped in that particular rock and that is attached there. So if we use the nanoparticles, the contact angles you can see it was more greater than 90 degree, and so only oils that was weighted with the surface of the rock, and if we increase different concentration of nanoparticles, it decreases the contact angles and then water weight with the rocks instead of oil weight. So by that way increase the oil productions, and water weight reservoir means oil weight reservoir to water weight reservoirs, means by using nanoparticles or nanofluids, surfactant nanopolymers, so we can enhance that oil productions rate. So here's nano silica that actually also used, so that I said already that decrease the contact angles, and therefore that also enhance that oil recovery. So here you can see that concentrations of the nanoparticles, silica nanoparticles. So any concentrations we cannot use, or it has been observed that if we gradually increase the concentrations of that silica nanoparticles, there it has been observed that with increasing the concentrations of the silica, the interfacial tensions and contact angle, that both will decrease with increasing the concentration of that silica nanoparticles. As a result, the oil recovery gradually increase. but any concentrations we cannot use at a optimum concentrations of that nanoparticles, that would be we have to use, otherwise that would be the stability of that nanofluid that we have prepared, that would not stable, so then that would not work properly. Okay, so here's a list of different type of nanoparticles is given: alumina, copper, ferric oxide, nickel oxide, magnesium oxide, tin oxide, titanium, zinc oxide, and how they work. So they change the interfacial tension, viscosity, and they as a result increase the oil's recovery from that risks by using these nanoparticles. Means these are the different nanoparticles and how they works when they are using with the polymer based or surfactant based fluids to prepare nanosurfactant or nanopolymer based fluids, nanofluids. So that changes the interfacial tensions as well as weightability and increase the means oil recovery from that particular rigs. So different type of materials means organic based, inorganic based, metal oxide nanoparticles, any particles we can use, and that depending upon that means which particular fluids are using which particular reservoirs where we are using, depending upon that we can choose the nanoparticles and we can prepare nanofluids that can be used for this particular purpose. Okay. So actually enhancing the nanoparticles I said, so that increase the stability of that the fluids that we have prepared, nanofluids. So here is the nanofluids. So outside that is surfactant that is coated, and after that if we use means some other surfactant, so it would be surrounded with polymers, so that would be form some clusters, mycelic clusters, so that would be trapped outside. By that way they forms a stable nanoparticles colloid formations, and that would be stable. So concentrations of these nanoparticles also very important. So a optimum concentrations we can use to prepare this nanofluid that form a stable nanofluids that would works for this particular applications in oil recovery. So today is up to this. So thank you. So we have studied different type of nanomaterials, and that is applicable by using or combining with the different type of nanofluid preparations, that is nano surfactants or nano polymers that we can prepare by combining nanomaterials with the specific base fluids, and that can be used for the trapped oils, that is the oils present inside of that reservoirs in that is attached with the rocks. So we can decrease the interfacial tensions by changing the contact angles in that particular oils and rocks that is attached in reservoirs, and by that way we can recover that trapped oils and increase the oil recovery performance. So thank you. So today is up to this.